At its heart, a computer's processor only understands one thing: machine code. This is a sequence of binary instructions, ones and zeros, that tell the processor exactly what to do. Writing this by hand is incredibly tedious and error-prone. The most famous example is the software for the Apollo guidance computer, which guided the Apollo missions to the moon. The programs were stored in wires. A wire going through a core represented a binary 1, and a wire going around it represented a 0. The weaving was done by hand, mostly by women at a factory, and was nicknamed the LOL memory for little old ladies. But thankfully now, we write in human-readable languages like Java, C++, or Python. The process of turning our code into machine code is called compilation. This is done by first writing source code, which is your program in, for example, a .java or .cpp file. Then, a compiler reads your source code, checks for syntax errors, and if everything is correct, translates it into a lower level language. The resulting file is then executed by the computer's operating system. So, why Java instead of faster languages like C++? The core difference between Java and a language like C++ lies in what you distribute and who does the final translation. With C++, the developer compiles code directly into native machine code, creating platform-specific executables. A .exe for Windows, a different file for Mac. The developer is responsible for building and distributing a separate version for every target platform. Java, however, compiles code into a universal intermediate format called bytecode. The Java Virtual Machine, a program installed on the end-user's machine, acts as the final translator, converting this bytecode into the native machine code for whatever computer it's running on. This is what we call write once, run anywhere. You compile your code once into a universal format and it runs everywhere. Secondly, in C++ or C, the programmer is responsible for manually managing memory. You have to allocate memory when you need it and free it when you're done. Forgetting to free memory leads to memory leaks, and accessing memory that has already been freed can cause crashes and major vulnerabilities in your security. Java automates this with the garbage collector. The JVM keeps track of which objects in memory are still being used. When an object is no longer needed, the garbage collector automatically reclaims that memory. Java has been a dominant force in enterprise software for 3 decades now. We have tons of powerful frameworks to use like Spring Boot and Hibernate. Also, there are countless libraries to handle databases, PDF processing, or calling a web service, and many more. Companies like Netflix, Uber, and LinkedIn use it extensively in their backend systems to handle massive scale and complexity.